Okay, so we're going to have a look at how to configure a site-to-site IPsec VPN using the Cisco command line interface. So here's a very much simplified topology. So we've got two sites, Site A and Site B. We've got router 1 at Site A with a PC attached, and we've got router 2 at Site B with another PC attached. And both sites are connecting to an internet service provider. And you can see that they are susceptible to interception by a man-in-the-middle attack from a hacker PC. So what we want to do is we want to enable secure communications between the two sites, and the way that we want to do that is by configuring a VPN tunnel between router 1 and router 2 between Site A and Site B. So we're going to set up an IPSec VPN tunnel. So this is the topology addressing scheme. So you can see that on router 1, the gigabit 00 interface has got an address of 192.168.10.1. So we're on the 192.168.10.0 LAN at Site A, and PC1 has got an address of 192.168.10.2, and the 000 interface of router 1 is the one that's connecting to the internet service provider with an address of 1.1.1.1. And at router 2, gigabit 00 interface is 192.168.20.1. So we're on the 192.168.20.0 network. And PC2 connected to that via a switch, it has an address of 192.168.20.2. And then we've got a 0000 interface connecting to the ISP router with an address of 2.2.2.1. And then we've got this internet service provider router, and we've got a hacker PC attached to that. The hacker PC has got an address of 172.16.100.2, so it's on its own network. And we want to prevent that PC from being able to intercept the traffic between router 1 and router 2 by configuring an IPsec VPN tunnel. So the objective to configure an IPsec VPN tunnel between the LAN attached to router 1 and the local area network attached to router 2. The hacker should not be able to decrypt the traffic in transit. So let's just have a look at VPN mechanisms. We need to consider confidentiality. So if our data is intercepted in transit because we're sending it over a public network, we need to make sure that the third party cannot understand it. So we need an encryption algorithm, and we need to use the same encryption algorithm at both ends to encrypt and decrypt the data. And we need to consider integrity. That's the integrity of the data. Has it been altered in transit? We can measure this by using a hashing algorithm. We also need to look at authentication. When we set up our VPN, we're setting it up between two routers at each end of our VPN tunnel. We need to make sure that we're actually talking to the right routers, that we're not looking at a man-in-the-middle attack. So we can do this using a pre-shared key or a public key mechanism. And we also need to exchange keys securely between our peers. This is normally done using a method called Diffie-Hellman. And we use a Diffie-Hellman group number. The higher the group number, the better. So let's have a look at the IPsec framework. The IPsec protocol consists of the authentication header and the encapsulating security payload. You can use one of those on their own or both together. For confidentiality, you can use the data encryption standard, or DES, or the more secure 3DES, which is the same as DES but it's encrypted 3 times, or the more secure advanced encryption standard, or software optimized encryption algorithm. For integrity, you can use Message Digest 5 or the secure hash algorithm. For authentication, you can use either a pre-shared key or you can use a public key method such as the Rivest-Shammey-Edelman or RSA. For key exchange, otherwise known as Diffie-Hellman, this is how you exchange keys between the peers. You can use a Diffie-Hellman group number starting with 1, but that's not very good these days. You tend to use the much higher group Diffie-Hellman group number, the better. We're going to use Diffie-Hellman group 5 just for this exercise, but obviously we recommend using a much higher number. We also need to look at something called IKE and ISACMP. This is Internet Key Exchange, IKE, also called Internet Security Association and Key Management Protocol, ISACMP. This protocol lets the two ends of a VPN tunnel agree on a security association, or SA. There are two phases. Phase 1 creates the first tunnel to protect the ISACMP exchanges, that's the IKE Security Association, and Phase 2 creates a tunnel to protect the data, that's the IPsec Security Association. So we need to create an ISACMP policy to set the terms of the negotiations between the peers for encryption, the authentication mechanism, a hashed message authentication code, or HMAC, and also Diffie-Hellman group. So if we look at the VPN choices for this exercise, for IPsec we're going to choose the encapsulating security payload. For confidentiality we're going to choose the advanced encryption standard. For integrity we're going to use the secure hash algorithm. And for authentication we use a pre-shared key. We're going to use a Diffie-Hellman group of group 5, although we recommend a much higher group, that would be better in practice. Now before we begin to configure our virtual private network on the two routers, router 1 and router 2, we need to install the security license module. So we say license boot module, and because they're a 1900 series routers, it's a C1900, technology-package, and then security K9, and this will be the security boot module. Then we need to then copy the contents of the current RAM to non-volatile RAM by saying copy running-config startup-config. When we've done that, we need to reboot the router by using the reload command, and then once it's loaded that security module, we're ready to go. So the configuration sequences, we're going to configure router 1 first and then router 2. So router 1 is at site A and router 2 is at site B. On router 1, for step 1, we're going to use an access list to define the interesting traffic from the router 1 local area network to the router 2 local area network. So we say access list and we give it a number. We'll use 120, permit IP, and then 192.168.10.0 is the network address of the router 1 LAN. Then we need the wildcard mask, which is the reverse of the subnet mask, and in this case it's 0.0.0.255. Then we use 192.168.20.0. That's the network address of the router 2 local area network, and then we give it the wildcard mask. So we're defining the traffic from the router 1 LAN to the router 2 LAN. And in step 2 on router 1, we're going to configure the IKE phase 1 ISACMP policy. So we need to configure the crypto ISACMP policy. We'll give it a number 10. We'll use advanced encryption standard, or AES, of 256 bits as the encryption algorithm. The authentication method, we're going to use a pre-shared key, and we're going to use secret key for that. We'll set the peer as the router 2 serial interface. We're going to use Diffie-Hellman group 5, although as we said a much higher group is recommended. So we say crypto ISACMP policy 10, encryption AES 256, authentication pre-share group 5, then we exit there. Then we say crypto ISACMP key secret key, that's our secret key, that's the pre-shared key. Then we say address, and then 2.2.2.1 is the IP address of the serial interface on router 2. So in step 3 on router 1, we're going to configure the IKE phase 2 IPsec policy. We're going to create a transform set, and we'll call this VPN-set. We're going to use encapsulating security payload. So for encryption, we're going to use the advanced encryption standard, or AES. And for integrity, we're going to use the secure hash algorithm, SHA-HMAC. So we say crypto IPsec transform-set. We're going to use the name VPN-set, then ESP ESB-AES, then ESB-SHA-HMAC. In step 4 on router 1, we want to create the crypto map VPN, and we'll call it VPN-map, that binds all of the phase 2 parameters together. So we're going to set up a security association. So we're going to use the sequence number 10 and identify it as an IPsec ISACAMP map. We'll set the remote peer as the router 2 serial interface. We're going to match addresses defined by the access list that we defined previously, the access list 120, as interesting traffic between router 1 and the router 2 LAN. So we'll say crypto map, VPN-map, this is the name we've given it, sequence 10, IPsec-ISACAMP, we'll give it a description, we set the peer 2.2.2.1, which is the IP address of the serial interface on router 2 at site B. We say set transform-set VPN-set, which we defined previously. Then we say match address 120, and this is the access list we defined previously with the interesting traffic. And in step 5 on router 1, we want to bind the crypto map that we called VPN-map to the outgoing serial 000 interface on router 1. So we say interface serial 000 crypto map VPN-map. Then on router 2 at site B, we need to configure things in exactly the same way, but obviously the addresses are going to be sort of reversed. So with step 1, we want to define the interesting traffic from the router 2 local area network to router 1 LAN. So it's the reverse of step 1 on router 1. So we say access-list, we use the 120 again, permit IP 192.168.20.0, and that's the router 2 LAN. Wildcard mask again, 192.168.10.0 is the router 1 LAN network address, and wildcard mask again. And then again on step 2 on router 2, we configure the IKE phase 1 ISACAMP policy, exactly the same as router 1, but the remote peer is the serial interface of router 1, which is 1.1.1.1. And then for step 3 on router 2, again, we configure the IKE phase 2 IPsec policy exactly the same as router 1 in exactly the same way. Step 4, create the crypto map, we'll call it VPN-map again, that binds all of the phase 2 parameters together. It's exactly the same as router 1, but we set the remote peer as the router 1 serial interface. We match addresses defined by the interesting traffic between router 2 and router 1. That was the access list 120. So we say set peer 1.1.1.1 in the third step in these instructions, which is the IP address of router 1's serial interface. And step 5, again, we bind the crypto map that we called VPN-map to the outgoing serial 00 interface on router 2. So then you'll need to verify the IPsec VPN. If you go to the command line interface on one of the routers and say show crypto IPsec SA, now SA stands for security association. So the outcome of this whole process is that you've set up a security association between router 1 and router 2 and vice versa. That's between the two sites. So then if you ping between, say, PC2 on router 2 local area network and PC1 on the router 1 LAN, and then do show crypto IPsec SA again, you should start to see some traffic appearing across the VPN. Then if you ping in the opposite direction from PC1 to PC2, again do a show crypto IPsec SA, you should see that you've got an exchange of traffic, and the process should now be 100% complete. Then looking at troubleshooting, if things don't work first time, you need to ask the question, are all the IP addresses correctly configured? What about the connectivity? Have you connected things correctly? You must use the same technologies and methods at both ends. So that's the authentication, encryption, the Diffie-Hellman group, and the same key method. So you're using a pre-shared key. Also, you must be using the same pre-shared key. We called it secret key in this case. Obviously, you need to use something more secure when you come to do it in practice. Have you missed out a step? Or have you mixed up a peer address? Have you used the where you should be using the IP address of router 2 serial interface, you've used router 1 instead, for example. So make sure that you don't do that. And hopefully once you've done a bit of troubleshooting, you should be able to get it to work. Hopefully it'll work first go though. And you might find this reference useful for further reading. You'll find it in the Cisco Security Appliance Command Line Configuration Guide, and it relates to configuring IPsec and ISACAMP.